everyone, welcome back to our channel. In the previous episode, we have learned how loops work. Today, we will further dive deep into loops. We do that with a problem-solving approach. We will write a code to find if a given word is palindrome or not. If you wonder what a palindrome is, let me tell you. Any word that reads the same from left to right and right to left is called a palindrome. For example, mom is a palindrome. So is the word noon. But you see, moon is not a palindrome word. Now, let's take a pause and try to write in plain English a strategy skeleton for identifying a palindrome. The strategy would be just like the one we created in the previous episode. Remember, in that episode, we first wrote a skeleton for finding if a word has the vowel O. It is now a good time to pause and try to come up with such a skeleton for identifying a palindrome. Well, one possible way to do this would be, for each start and end letter X and Y respectively in a given word W, check if X and Y are the same. Then do nothing else, print not a palindrome. First, remember that this is a skeleton, so it doesn't need to be perfect in the Pythonic syntax. Next, from the appearance, this skeleton looks good, but we still need to address a few open items. For example, consider the starting line for each start and letter, etc. etc. This line is fine for the first iteration, but what happens in the next iteration? How does the computer know that for the start letter X, we need to move one step towards the right? And similarly, for the end letter Y, we need to move one step towards the left. One way to fix this is by moving explicitly to the next characters. So we modify the skeleton a bit. Now it looks like this. First note that now onwards we will clearly indicate where a loop or a decision block ends by mentioning N for, N if, etc. This avoids any confusion with new lines. Next, note that this skeleton looks much more detailed than the previous one we have just discussed. But there is still a minor catch. The fact that we move X and Y explicitly because for in loop might not be useful here. This is an indication that we should try out for another loop command. So we will now see whether a while loop works here. Additionally, we will use indexes to indicate the characters. With these changes in place, the skeleton will look something like this. F index stands for forward index and R index stands for reverse index. In fact, in the following loop, we will move F index forward and R index backward, one step at a time. First two lines initialize the indexes to be used for accessing the characters of the word W. The F index accesses the characters from the start and the R index from the end. Then we have a while loop which loops as long as the condition forward index is smaller than the reverse index. So I guess you can make sense out of it that we start with two indexes standing at the head and tail of a word. Then we must move them closer to each other in each loop until they cross each other. The crossing each other is codified as the loop condition. And this crossing happens when the forward index is no more smaller than the reverse index. See, the indexes are modified at the end of the loop body. Forward index moves one character right in each loop, while the reverse index moves one character left in each loop. Now, we need to compare the characters in the loop body as well. The forward character is X and the reverse character is Y. The decision block does the job of comparing and taking the decision actions. Now, we are almost done. All that is left is setting the X and Y. Since X and Y depend on the indexes, we must set them each time we enter the loop body. Now I'm sure the full code makes sense to you. Well then, let's see this in Colab in the actual form. Let's run this with the word moon. W equals moon. See, it prints the moon is not a palindrome. Notice that when the word like moon is not a palindrome, this code also prints the same. But when the word is in fact a palindrome, it prints nothing. Let's verify this with the word noon. This is a flaw in this code because the code does not say the word is not a palindrome. To fix this, we need to modify our strategy a bit. First, note that we cannot just add a print command. W is a palindrome in the if block instead of doing nothing and passing. With palindrome words, this print in if block would work just fine. But with non-palindrome, it will print the word is not a palindrome a couple of times. And then, finally, it would print it is a palindrome as well. We can see this in the Colab. How bizarre it would be. See, it prints contradicting statements. I'm sure this should convince us that for a palindrome word, we need to hold our decision until we finish looping all characters. Also, we need some identifier that holds and modifies our decision about the word being a palindrome or not. When in a loop, we find that any pair of X and Y are not matching. We can call out that the word is not a palindrome. But if there is a match, then we don't modify the last status. In the end, we can use this identifier to make the final printing decision. Let's look at our modified code. We use a new variable, isPalindrome, as the indicator of our decision. We set this variable to true. So at the beginning, it indicates that this word is a palindrome. Then, during the looping, if each word matches, then the status will not be touched. So when the loop ends, this will remain true as we expect for a palindrome word. But if the word is not, then some X and Y will mismatch. Then in the else block, this decision variable, isPalindrome, will be modified to be false. In the subsequent loops, this false status will not be modified even if all other pairs of X and Y are matching each other. Thus, once this variable is marked false, it will either be rewritten as false during other mismatches or never be touched during other matches. So when looping ends, a non-palindrome word will always leave this variable, isPalindrome, as false. We also add another if-else block at the bottom. Based on the value of the variable is palindrome, this block prints whether the given word is a palindrome or not. Now let's run this code in Colab. See, it prints not a palindrome as we expect. Let's also try it with the word noon. See, now it prints a palindrome. We are almost done for today. This example should provide you an insight about how a while loop can also be useful. Finally, before we close for today, a food for your thought. Consider a non-palindrome word whose first and last characters are not the same, say hypothetical. Now if we look at our code, we would notice that in the very first loop, after comparing the first and last characters, that is H and L, we know that it is not a palindrome. Yet we would still iterate over all other characters before we finally print the correct result, which is hypothetical is not a palindrome. See, all these loops are not required. They are unnecessary, overwriting the same false value again and again. The question is, what would you ask from Python to stop the code from iterating unnecessarily? Can we stop as soon as we identify a mismatch between the character pair of X and Y? Put your thinking hat on and try to solve it. See you soon. Ciao!